Okay, you're right. Welcome to your tutorial on surface area. Today we are going to look at how to calculate surface area. So let's begin. What is it? Surface area is the area of all the outside faces of a three-dimensional object. So far we've just looked at 2D objects. So squares, rectangles, trapeziums, parallelograms, and we've looked at finding the area. They're 2D objects. Now we're going to move on to 3D objects, like our little Rubik's Cube here, and we're going to work out how to work out surface area. There's a keyword in there that gives it away. We're going to work out the area of the entire surface of these objects. Now what this is going to require you to do is not learn any new formulas, but rather apply the formulas that you know to a problem that you don't know. So, let's have a look at what I mean. Okay, to find the surface area of an object, we need to identify the shapes of the outside faces of the object first. Now that Rubik's Cube was pretty simple. It was a cube, so all the outside faces are squares. Okay, whenever we look to find the surface area of an object, firstly we ask ourselves, okay, let's have a look at this 3D object and what shapes make up its surface. Then, taking each face separately, we need to find the area of all of them. So if it was a Rubik's Cube, we need to find the area of one of the faces, then the other face, then the other face, then the other face, then the other face, then the other face. We need to know how many faces there are altogether on the object. So the first thing is identifying. The second thing is being able to calculate how many faces there are by looking at a diagram. And it takes a little bit of spatial awareness, okay? So let's have a look. Let's have a look at the first example. It says, find the surface area, and it's of this object below that I've written here, okay? So we have a cube. And just by looking at this cube, I can see that there are some measurements on it. Okay, and there's 5 by 5. When I look at this face here, one of their faces, I can tell it is a square. Now, the best thing to do is to start solving these problems by drawing a net. And how we draw a net is we start with the centermost or the base shape, and then imagine like we're unwrapping a present. We unwrap the right side, and the top, then the left, then the other side, then the other side. And if I unwrapped it, so I started with my base here, I unwrapped this side to there, the top over here, this back side up there, this right side over there, and this front side down there. That's the kind of net I would get. What a net helps us do is it helps us to accurately count all of the sides. So rather than just looking at this 3D object and saying, kind of tilting your head around and going, okay, 1, 2, 3, 4, we can sometimes miss the faces. The most common face, sorry about those cars, the most common face to miss is this top one, forgetting to add the top one. So we counter our error by drawing a net. Now this net will label these are 5 centimeters by 5 centimeters each of my sides, okay? And if I work out the area of my base, let's try that. The area of one square, I've shortened that to 1 square. Area of 1 square is 5 by 5. So the area of one of those is 25 centimeters squared. And I have 1, 2, 3, 4, 5, 6 faces. So if one face is 25 centimeters squared, the area of the entire thing will be 25 centimeters squared times 6. And the surface area of that then would equal, area equals 150 centimeters squared. So it's pretty simple, guys. 6 times 25 centimeters, equals 150 centimeters squared. Main things to remember is the drawing of this net, okay? Draw the net so it will help you deal with each shape separately. let's go on to a bit of a more tricky one. Let's find the surface area of this object now. Now, it's not a cube. It's another 3D object. It's actually a square pyramid, okay? In order to work out the area of the square pyramid, in order to work out the surface area of it, guys, we deal with each face separately. This particular question, a net will be particularly helpful. That's why I did one in Photoshop first, okay? So, this is my net here. Okay, I've started with my base. So I've started with this guy here. Okay, and I've put him in the center. And then I've drawn each of the faces going out. Now, this square that's at the bottom, okay, it's been told it's 4 by 4. Okay, so when I've drawn it in my diagram, in my net, I can either write 4 on all the sides, or I can actually just do these little lines to indicate to myself that each side is equal, or each side is 4 centimeters. So we'll deal with each shape separately. Let's first work out the square. So the area of the square at the bottom is equivalent to 4 by 4. Okay, I got that measurement from there, and I know this side is equal, so it'll be that side times that side to work out the area. 4 by 4, 16 centimeters squared. That's the square. The area of each of the triangles, see how I'm putting these little letters here, the T and the S? The S represents the square, the T represents the triangles. Okay, the area of one of those triangles, okay, is worked out with the formula for a triangle. And remember, our formula for a triangle is, that's moving everything. Our area for the formula of a triangle is half base times height. So what I'm going to do is I'm just actually going to rub this out. Okay, I know this one here is 16 centimeters squared. Okay, and now our area of the triangle is equivalent to half base times height. That's how I work out the area of a triangle. Now my base, how far is it from here to here? Or here to here? How do I know that? All sides are equal, so the length from there to there is 4 centimeters. So the area equals, I'll just put equals underneath each other, equals half 4 times 6. Because on the diagram, it has shown me that the perpendicular height is 6 centimeters. That's why I've done the 6 centimeters on my diagram. So half 4 times 6, 2 times 6 equals 12 centimeters squared. What does that 12 centimeters squared represent? That 12 centimeters squared represents the area of one of these triangles, one and one only. I have 1, 2, 3, 4 triangles. So I must write the total area of the triangles is 12 times 4. So my total area of the triangles is 48 centimeters squared. So 1, 2, 3, and 4 equal 48 centimeters squared. Then I've got 16 centimeters squared. So 48 and 16, get rid of all of this, 48 and 16. My total area total equals 48 plus 16, which equals 64. Whoops, sorry, I was going to write 5 for some reason. I don't know what I was doing there. 64 centimeters squared. So what I've done is I've worked out the square on the bottom first. Then I've worked out the area of one of these triangles and multiplied it by how many ever triangles I have. Then I've taken the square measurement, the triangle measurement, added them together to get 64 centimeters squared. Deal with each face separately. To make sure you don't skip a face, draw a net. Okay? It's as simple as that, guys.